Hey guys, it's Mr. Hebrek with your notes for lesson 7.3. We're going to be talking about, logarithmic functions. A logarithm is the inverse operation for an exponent. So if I have an exponential equation that looks like this guy right here, b to the x equals a, then the corresponding logarithm is going to be log base b of a equals x. And we read them this way. So, like I said, if b to the x power equals a, then x is the logarithm of a in base b. Now, what does this actually mean? Well, like I said, these guys are inverses of each other. So if you look down here at these examples, here we have 3 to the 4th equals 81. Our base is 3, our exponent is 4, and the value, or the a, is 81. So if I rewrite that, it would be log base 3 of 81 equals 4, right here. Here, I can go back the other way too. If I have a logarithmic function, its inverse is an exponential. So if I have a log base 5 of 125 equals 3, the base, it's the little guy down there, is 5. The exponent is what it equals, 3. And the value is right here, 125. So I can put those together as 5 to the 3rd power equals 125. Now here, if no base is written, then we assume the base is 10. And if you look on your calculator, you'll probably see a button that looks something like this. It says log. And the second function of it will be this guy here, 10 to the x. So basically, if we have a log without a base, we assume the base is 10. So here, log of 100 equals 2. That means 10 squared is 2, because we assume the base is 10. So let's work out a couple examples here to see what we're talking about. Here I have 7 squared equals 49. My base is 7, my exponent is 2, and my value is 49. So if I want to rewrite this as a log, I'm going to say log base 7 of 49 equals 2. So the base, the base down here, the exponent on the other side of the equal sign, and its value, 49. 6 to the 3rd is 216. My base is 6. My exponent, x is 3, and its value is 216. So that means that log base 6 of 216 equals 3. 2 to the 5th equals 32. Now, after you've done a lot of these, you probably don't have to write everything down, but I'm going to anyway. Base equals 2. My exponent is 5. And the value of the exponential equation is 32. So that means I could say log base 2 of 32 equals 5. And as I said, you can translate back to exponentials if you have the corresponding log function. Log base 9 of 729 equals 3. My base is 9. My exponent is 3. And its value is 729. So 9 cubed, or 9 to the 3rd, is 729. Over here, log base 2 of 64 equals 6. Question number 5. My base is 2, my exponent is 6, and the corresponding value is 64. So this would be 2 to the 6th power is 64. Here I have log of 1,000 equals 3. And remember what I told you. When there is no base, we assume the base to be 10. The exponent is 3, and its value is 1,000. So what we end up with is 10 cubed equals 1,000. Now just a few little things as you're working on your homework. couple things to note. There's some good examples in the textbook you should definitely look at. But if I have something like this, remember that b to the first power is b. So that means that log base b of b is always going to be 1. If your base and your value are both the same number, excuse me, then the log value is always going to equal 1. So as an example, log base 5 of 5 is always going to be 1. Excuse me. Now, remember that any number to the 0 power, doesn't matter what it is going to equal 1. So if I have a log base b of 1, the exponent has to equal 0. So if I have log base 5 of 1, then it's going to equal 0. You might be asked to figure out some things here. You're going to be looking at your homework and you're going to have to do some mental math. It's not hard. Let's say I have 2 to the x power equals 32. So basically I'm looking for a power of 2 that equals 32. Well, if I could just, like we did up here, realize that, well, 2 to the 5th equals 32, so x has to equal 5. In the homework, when they ask you to do this mental math, it's not going to be really all that tough. You're going to have to know your times tables a little bit, but I think you can handle it. We'll do the graphing, which is the second part of this lesson, tomorrow. So for now, this should get you started. As I said, if you look at the examples provided in the textbook, they should help you out quite a bit. And if you have any questions, just drop me an email. I'll see you guys soon.